Hi guys, welcome back to the tutorial series. So today I'm going to talk about k nearest neighbor algorithm. This algorithm is the simplest supervised machine learning algorithm. So which is used for classification and also regression. In my previous series I have already explained when do we go for classification and when do we go for regression. So if your target variable is categorical type, then you go for classification, and if it is a continuous type, we go for regression. So one of the advantage of this algorithm is it is used for both the purposes, and this algorithm is non-parametric. It means that no assumptions required for data distribution. Now let us see how the algorithm works. So first of all, you need to pick up a value for k. So what is this k? So k means the number of groups. So you are segregating data into different groups, right? So in that case, you have to choose the value for k, and this is prerequisite. It means input. So while building a model, you have to specify the value of k. And then once you decided the value of k, then search for k observations in the data set which are nearest. Means the observations means rows here, so samples which are nearest. Then the question is, what do you mean by nearest? How do you find it? So here you can use distance finding metrics like Euclidean distance. So Euclidean distance means when you consider 2 points x1 y1 and x2 y2, then the distance between these 2 points can be calculated as we can denote with d. So d is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So that is calculation of distance, and we no need to worry here, the algorithm automatically calculates. And then use the most popular response from the k nearest neighbors, means the one which is giving you the less error value. So let me explain you this with sample drawing here. For example, you have two groups. So this is the one group and this is the another group. Let's say you have some cats here. Okay, cats, and here you have some dogs. Okay, cats, dogs. Here set of dogs. Now if you give some unknown data, the algorithm has to make a decision whether it belongs to this group, cats group, or whether it belongs to the dogs group. So then how it determines? So it based on the features, based on the similarity, what it does it, if the features of the new object is matching with the cats, then it will classify this into this group. Else, if the features of the new data is matching with the dogs group, then it will put that into the dogs group. So this is how the algorithm works. Now you might have a question here, how to know the optimistic value for k. The answer for this is the value which produces the most accurate predictions on unseen data or test data, then that is the best value. So machine learning is a trial and error approach. So you take some value for k, then with that k value, if your results are not good, then you have to change the value. You can increase or you can decrease. So that is how you can determine the value for k. At last I'll show you how to know the optimal value for k. So in order to demonstrate or in order to build a KNN model, so I'm taking the simpler data set, that is iris data set. I already introduced what is this iris data set in my previous sessions. So iris is one of the very famous data set on which everyone should have hands on, and it is a flower data set. You have to do classify the flowers. There are three types of flowers: Setosa, versicolor, virginica, and there are totally 150 samples, and the segregation of samples in the training data set is 50 plus 50 plus 50, means 50 samples belongs to the iris Setosa class, next 50 belongs to versicolor, and next 50 belongs to virginica. So we'll see that. Then what are the features? The features are sepal length, sepal width, petal length, petal width. So based on these four features, you can determine the type of species means flower type here. So this is the problem statement. Different species of the iris plant has to be determined. So we have to predict the value for species. So here I'm importing pandas to create a data frame. I'm importing matplotlib to do the data visualization, and I'm importing metrics like classification report, confusion matrix, and accuracy score. So these three are the model evaluation metrics. And if you don't know what is the meaning of classification report, confusion matrix, and accuracy score, you can now see my previous videos. So I have explained them clearly in my one of the video in decision trees. And then importing warnings and filtering the warnings means if there are any future warnings, you can ignore them. So when I run this, all these libraries are imported. And then here also I'm directly loading the data from UCI. It's an online repository where you can find a set of open data sets. So this is my URL. Then this data set is not having the column name, so I'm creating a Python list here. Calls name, which is user defined, which is equals to sepal length, sepal width, petal length, petal width, and then spaces is the target variable. Then here I'm creating a data frame. Iris is equals to pd dot read underscore csv. The data is read from the URL, and then it is not having the columns, so that's why we are writing header equals to none, and names is equals to the column names. So these column names are applied on the data set, and then iris dot head. So we are displaying the header part of the data, means by default first 5 rows. So spaces is the target variable, and then we have 4 features. You can put them into X, into Y, you can put spaces. Then I'm checking the shape of the data. So 150 rows are there, and then 5 columns, as you can see in this the output of 2. Then I'm also checking the class distribution, means how these samples belongs to 3 classes. You see 50 samples in Setosa, 50 samples in versicolor, and 50 sample in virginica. So equal distribution. So this is a clean data, so we don't need to worry about any data pre-processing required over here. Then feature columns. So these are the feature columns, means this one. I want to put this into X. So taking this 4 into the variable, taking those 4 into the variable feature columns, and then X is equals to iris of features, means these 4 columns are put into X, and spaces is assigned to Y. So I determine what is X and what is Y. Then I'm checking the data type of X and Y, X and its values. So X is data frame and its values are numpy array type. So it's a 2-dimensional. And then checking the shape of Y and also its values type. So Y is series, pandas series. Series means 1-dimensional. Data frame means 2-dimensional. And checking the value type, so they are numpy array. Then checking the shape of X, 150, 4 columns. Similarly checking the shape of Y. Shape means rows and columns. So we have 150 rows and it is single column, so single dimensional. This one is 2-dimensional, rows and columns. Then importing this train test split from scikit-learn.model selection module. Then we are splitting X and Y into test size 0.2, means 20%. So training size is 80%. Random state we mentioned 0. Then it is split into 4 parts: X train, X test, Y train, Y test. Then we are importing algorithm here. K neighbors classifier imported from the module neighbors from scikit-learn. So once the algorithm is imported, the next important step is creating an object, means building a model here. So knn1 is a user defined variable model name, and knn neighbors of, so I'm giving k equals to 1. So k equals to 1 means all these samples are considered to be put into a single group. So initially we are taking k equals to 1, and later I'll show you by taking multiple more than 1. So the object is created, and this the model has built, but it does not learn unless until you fit your data. So fitting the data to the model. So we always fit training data, train dot values and y train dot values. So the model has learned over here. So here you need to follow the steps, basic steps. So first is importing algorithm, then creating object to the model, then fitting data so model has learned. Next step is making the prediction. So I'm just using sample values here. Sepal length 3, width 5, petal length 4, width 2. So this is just sample data and then what the class is predicted. So the model has predicted that this particular sample is Virginica type. Okay, it is Virginica type. So based on the feature values, it has predicted it's a Virginica type. Now if I give two samples, then what the model will do? So it will make the predictions for the first one Virginica and second one is versicolor. So like this, if I give my 20% of test data, then model will make the predictions and then checking the accuracy here. Accuracy score between y test means actual value, pred means what the model has predicted. So if there is a difference between these two, test and prediction, we say there is an error. For example, actual is Virginica, the model has predicted versicolor, means incorrect, so that's an error. So on the test data there is no error, so model has given the accuracy score as 1.0, means 100%. Now again building another model, but this time I'm taking k equals to 3. K equals to 2, so creating object, fitting data, making the prediction for x new. So x new means we have created over here, and the first model has predicted output for x new. Output for x new as Virginica for the first sample, Virginica, and for the second sample versicolor. So if I give this same value, then what my second model will predict? It has predicted versicolor. So there is a difference. The first sample is the first model saying the first sample is Virginica type, whereas the second model saying is versicolor. So there is a difference. So there is an ambiguity. So which model is correct? First one or second one in case of first test data? In case of second one, so here also this is giving versicolor and second model also saying versicolor, means there is no difference. So the problem is with the first one. Now how to determine, so what is the right class for the first sample 3542, either Virginica or versicolor. So in order to determine this, so you can go for predicting the probability value. So knn2 dot predict probability of x new. So you can see the first sample 66% it belongs to the second class. What is second class? 0 means versicolor setosa, then this one is Virginica, saying it 66% it belongs to the versicolor. Second class is versicolor, third is Virginica. So 66% to the versicolor and 33% to the Virginica. So what is the maximum? The maximum is 66. So we conclude that it belongs to the versicolor type. Similarly, making the prediction for X test and then evaluating the model. So the accuracy is 96%, means 4% it can make mistakes. If you round this value, so we can finally say 97%. So 3% it can make mistakes. So like this the model is built and you are making the prediction and evaluating the model. So as I said before, how to determine the k value. So here we are just doing a trial and error approach here. So importing numpy and then errors. This is Python empty list and using while for loop for I in range of 1 to 41. Means range means always takes one value less. So 1 to 40 actually. So these models are developed and then knn equals to neighbors of, what is the k value? K value over here is n neighbors means k. So k value over here is I means I value is ranging. So totally, and we are fitting the complete data here. So totally 1 to 40 models are developed. Okay, 1 to 40 models. And then making the prediction for X test, the results are stored into the pred. And if there is a difference between the predicted and actual value, we consider that as error, and taking the mean value and appending to the error. So as you can see here, the model has been built. Okay, model has been built, and then so we are just looking at the error. So having a plot here, plt dot figures, so specifying the figure size 10 by 6, and on the graph we are plotting the range value, and then error, so which we got it from the above cell 22. Then color is red, line style is dashed, marker type is O, face color is blue, marker size is 10, and this is the title of the figure. This is k value, x-axis label is k value, and y-axis label is mean error. So look at this graph. So from this graph, what we conclude is, if we take k value as 14, then error is more than 0.03%. So here we should not take this. Understand? We should not take k equals to 14. Even if you take this, for example, if you take these values, it could be around 28, from 28, 29, 30, 31, then your error is high. So it means that you need to take only, you need to take only these values. Got it? You need to take only these values. So when you take these values, k value, on x-axis you are showing k value, and y-axis mean error. So when you take these values, then the error is 0. So we should take k equals to 1, 2, 3, 4, 5, like only this. Okay, only that, but not k equals to this. Even these are also not fine, because your error value is more than 0.03. So this is very higher. This is very higher, almost 0.065 something. So we should not take these values. So that is the analysis. Okay, that is the analysis. So we should not take this. Next we'll compare we compare KNN with other models. So what are the advantages and disadvantages? So the advantages of KNN model is, it is simple. It's one of the very simplest algorithm which is used for classification and regression. And training is somewhat fast, but when your data size increase, then this is not true. And benefit is used for both classification and regression. Then what are its drawbacks? So drawback is k value must be determined first, and must store all of your training data. You should better fit all the training data. And prediction phase can be slow when n is increased. N means number of observations, number of samples, and it is sensitive to the irrelevant features and the scaling of the data. And this is the point to be noted, as it is a very simplest one. The accuracy is not that much competitive. Accuracy is not competitive with other supervised machine learning algorithms. So that's it about this, and hope you have got some knowledge from this, and you have understood how to build a KNN model. If you have any kind of data, then simply you can follow this process and you can build a machine learning model. So feel free to reach out for any queries and also any questions, and do subscribe our channel for more updates.